we have talked about different ways to display data in stem and leaf plots, in histograms, in relative frequency histograms, and then relative frequency histograms tie you back into circle graphs because you need to create them to make your circle graph. So now we're going to start thinking about, well, what else can we do with this data? And today we're going to start focusing on measures of dispersion. And we're going to focus on 12.4 today, and leading in tomorrow we'll do some fun activity on Wednesday. So this is all we're going to be doing this week is 12.4. When we come back, do not forget everything that we've talked about, because we only have a few sections, I think 6. Let me make sure I'm not lying. I think it's 6 sections in chapter 12.
Yeah, it is.
Is it?
Yeah.
5, binomial distribution, normal distributions. Yeah, so that's it. So there's 6 sections left. So that means a quiz will probably be occurring the week that we come back. And then your test will probably be coming up fairly shortly. Remember, we only have 2 full weeks when we come back from break before midterms. Okay, so 2 full weeks and then midterms. And this is the last chapter that we have for this. So once we get through chapter 12, then we are done and we can spend some time reviewing for that midterm. Remember, on your midterm, you are allowed one side of a normal 3x5 index card.
One side?
Only one side. 2 sides for final. Final is 2 sides. 1 side for midterms. I will share with you as a Google Doc tomorrow, and I'll have hard copies of a review for you to start working on over break if you so choose to, or not. So that's that, okay? All right, so measures of dispersion. We've talked about different types of measures. Mean, median, and modes are different types of measures. When you hear the word dispersion, what do you think of? Like when you disperse something, what does that mean? Well, you don't really, what happens when it spreads, right? So when we start talking about dispersions, we're going to be looking at specific type of spreads within the data. Now, you already know 2 specific type of spreads, range and interquartile range. Those talk about spread of data, right? Interquartile range, Q3 minus Q1, range, max minus your min. So now we're going to use these measures to get different types of dispersion. So here's your first one, or our first definition of it. Measures of dispersion. This is what we just said, but in a much better mathematical format. So measures of dispersion indicate the extent to which values are spread around a central value such as the mean. So for today, when we're talking about our measures of dispersion, we're thinking about what is that spread around the mean. So if you think about a histogram, one, 2, 3, 4, 5. Take an estimate on where you think that mean would be.
3.2.
It'll be somewhere around 3, right? Because if you look at the display, our center value is occurring right about here, and it's pretty symmetric, except for this is a little bit higher, so maybe our mean would be a little bit closer to this end. So we're looking at that spread around the central mean. So the first deviation that we're going to be talking about, just write it down. That's up to you. Definition might help make sense of what that formula looks like. So another way to talk about dispersion is the way that something deviates from something. So if I talk about the mean deviation, what I'm talking about is the mean of the absolute values of the differences between the data values and the mean. What is that, you say? I will explain what that is. You will not need to memorize this formula. You will not really use this formula. I mean, technically you are using the formula. It's just you don't really know that you're using the formula. So this is what this formula is talking about. This fancy, this is called, that's a Greek letter. Does everybody know what that Greek letter is called?
E. Is it the sum? Doesn't that
It does mean the sum. It's sigma.
Sigma.
So sigma talks about taking the sum of things. Well, if you were going to find the average, what do?
You take the sum.
You take the sum of things and divide by
The number.
how many things there are, right? So that's that 1 divided by n. This just is telling us that you're starting at the first term going to the nth term. Absolute value, we all recognize the absolute value symbols, right? The difference means I'm going to do what operation? Subtraction. And so I'm taking the difference between the data values and the mean. So I'm subtracting whatever my data value is and the mean, taking the absolute value of it, adding them all up, and dividing by the number that are there. That's what that formula stands for. Okay, we use the same formula in AP Statistics, but they don't use it. It's just there. Someone had to make a formula to say it works because of this. But we don't really use that. Okay, so let's go ahead and do this. Go ahead and take a second to get this data copied down. And I am going to get rid of this part B because that's not enough space. So what we have are test scores. I have it frozen on purpose. For 2 courses, history and math. And the first thing we want to find is just the range and the mean deviation for the test scores. My iPad's not catching up. Had a little delay there. Okay, so let's start with history. Can we? Oh, is everybody okay? Do I need to pause? I'll pause.
Is it the range of both of them?
Well, we're going to have to do 1 for history, 1 for math. So we're going to have 2 different ranges. Or do we want to put it all together?
We can just do for each.
Just do 1 for each. Let's just, do you want to do history or math? You want to go history? All right, we'll go history. So let's do it for history. I think you'll get the idea if we just do it for one topic. All right, so history. What would be the range for this student's history test scores?
8.
What am I doing to get that?
Subtracting the minimum from the maximum.
So my max is what number?
91.
And I'm subtracting the minimum, which is
Oh, wait.
85. So my range is 11. Good. All right, is everybody okay with finding range? Okay, so now to find the mean deviation, I need to find the absolute value of my data point and subtract the mean. So in order for this to work, I have all my data points. Data point 1 is 85. Data point 2 is 91. Data point 3 is 96. Data point 4 is 85. Data point 5 is 93. So the only thing that's missing is the mean. Can we find the mean of the history scores? Very easily. Let's do that really quickly. Let's find the mean. So grabbing your calculator, start adding up those 5 test scores, divide by 5. Are you guys getting 450 when you add them all together? Yeah. So then when we divide by 5, we're getting a mean of 90. All right. So what the mean deviation is giving me is I'm really asking myself, well, what's the deviation? What's the dispersion? What's the spread that each specific test score is away from 90? Well, how far away is this test from the mean? 5. How far away is this test score from the mean?
1.
This test score is
6.
This test score is
5.
This test score is. So, reason why we do absolute value is if I do test score 85 minus 90, I'm not going to say that it is negative 5 away. It's just 5 away. Right? So does that make sense? So then what we're going to do is we're going to take all those numbers and we're going to take the sigma to them. So that means we're going to add them and then we're going to divide by how many that we had to find that mean deviation. So sometimes it helps to make a quick list. So if my test scores were here, we had 85. So then my absolute value of x minus x bar would be what? 5, right? If my test score was 91, it would be 1. At 96, we said it was 6. At 85, we're at 5. At 93, we are at 3. Okay. So that's my deviation. That's how much my test scores deviated from the mean. So then to find the mean of the deviations, what are we going to do? Add them and divide by 5. Good. So let's do that. So my mean deviation is going to be equal to 5 plus 1 plus 6, which is 12, plus 5 plus 3 divided by 5. So 20 divided by 5 is 4. So my mean deviation is 4. Okay.
Can you put the symbol for mean and then put deviation?
Sure, you can do that. That's fine. So we found the range. We found the mean deviation. That looks complicated. That's not so complicated, right? As long as you can find your mean, and it's just how far away did the test deviate from the mean, and then find the average of those. Okay, part B wants us to describe what these measures indicate. Well, what does that mean? It's another word for mean. Average. So I could say on average, Bob's test scores were what?
For 4 away from 2.
Were about 4. Were these percents? We're talking percents probably, I'm assuming, right? 4% from the mean. So on average, if I could spell average, that'd be awesome. The students students. If I could spell students, that'd be awesome also. The students' test scores deviated from the mean by 4 percentage points. All right, so that is how you find mean deviation. So now we're going to step up our game. We're going to learn 2 more measures of dispersion. Mean deviation does not get used as much because it doesn't give as much oomph and emphasis to the data. So what we're going to do, how many of you guys have heard the word standard deviation before? Have you heard the word standard deviation before? So standard deviation is the most commonly used in the statistical world type of measure of dispersion. But before you can get to standard deviation, you need to understand how to get to variance. You can write them down or not write them down. You're not going to use these formulas. If you just want to pull it apart, you can go from there. Well, let's pull it apart. What's this telling us what we're probably going to do? We're going to probably find the average of something, right? Okay. In the mean deviation, what did we do with my test scores and the mean? We took the absolute value. Okay. Well, instead of taking the absolute value, when we go to find variance, we are going to square the difference between your test score and the mean. Then to go from variance to standard deviation, we just take the square root of the variance to undo the square. While you're writing that down, I will help explain things a little bit better. So what were our test scores? 85, 91, 96, 85, and 93. All right. So if you remember from what we just did in the last example, we had the following history test scores. We said our mean was what? 90? Yeah? So what is the deviation of the score of 85 to 90? It's 5. And if we did 85 minus 90, I would get a negative 5 answer. Here, 91 minus 90 gets us to 1. 96 minus 90 would get us to 6. 85 minus 90 would get us to negative 5. 93 minus 90 would get us to 3. So if I were to take the average of these numbers, well, first of all, let's add these numbers. What's negative 5 plus 1? Negative 4 plus 6. Minus 5 plus 3 is 0. Which it should make sense that they should balance out because your mean of all the scores should be getting you to 0. So if I had to find the average of 0, that would get me to what? 0. So to get rid of that 0, that's why to find the mean deviation, they take the absolute value of your differences. To find the variance, they're going to square those numbers. Well, what are those numbers squared? What's negative 5 squared? 25. 1 squared. 1. 6 squared. 36. Negative 5 squared. 25. 3 squared. 9. Now if I add those and average them, am I going to get 0 anymore?
No.
No. What do I get?
A different number.
How do I not keep bringing my calculator up here?
35, 60, 90.
96? Is that what it is? 96. So if I wanted to find the average of those, what would I divide by? 5. What's 96 divided by 5? 19.2. Right there, you just found your variance. This is lowercase sigma.
Sigma.
So then, how do we get it to just standard deviation? That's a really bad one. Just square root it. What's the square root of 19.2?
No clue.
Thanks for the help, Cole. Appreciate it.
4.38.
3.8.
38.
So that means, I mean, that's pretty close to what we got before. We said it was 4. Is that what we got for the mean deviation? So for standard deviation, it gets it a little bit more exact. It gets a little bit more precise. So our standard deviation would be 4.38. So that means that the scores vary from the mean, that central data point, at about 4.38 percentage points. Okay? All right, let's try... I don't want to do that. Let's come up with a new one. All right, here's some data points. How about let's do this for data points. Everybody get out your phones if you have a phone. I want you to look on your photos and find how many photos totaled your phone has. If your phone doesn't tell you, it should tell you at the top, doesn't it? All right. Just photos. Or I think you can go to your general settings and like look at your memory or something like that, and does it tell you how many photos are in there? Yeah. All right. I'm going to come around and ask. If you don't have it, don't just say pass. Erica.
705.
Haley?
I'm good.
Maddie, do you have it? 1,578.
1,786.
She doesn't feel so bad now. What were the last two numbers? 1,786. Cole, what do you got?
356.
200 and 1, 2, 3, 4. Really? Abby. Guys, I can't hear. 2,541. Ben? Andy, do you have anything?
Yeah, it's 1,530.
Mac?
2015.
2015?
2000, no, 2050.